Hey, here we go. Hello, good evening, good morning, good afternoon, good night, whenever you're watching this, 7 a.m., 7 p.m., 4 in the morning, whenever you're getting your math on. Happy to see you today. So today we're looking at learning target number 3 about calculating the surface area of a right triangular prism. So we're going to utilize a couple different things that we've talked about already. We're going to need to know the area of a rectangle is length times width, and we're going to need to know that the area of a triangle is our base times our height, and this base and height, it needs to be it needs to form 90 degrees. So if you take a look at this right here and this right here, that's a 90-degree angle right there. And so this is going to be your base, and this is going to be your height. On a triangle of this style, you will not see a 90 degree. So you're going to see something like this probably on the triangle, and you're going to see your base is going to be down here, and your height is actually going to be that from the bottom to the top right there. That's going to be this measurement that's on that dotted line. So it's going to look a little bit different depending on the triangle that you're using. So taking a look at using a net, we're going to see surface area using a net first. And we know that a right triangular prism has got 5 faces. It's got 3 rectangles, right on this side, on this side, and on the bottom. And it's got 2 triangular faces on one side and on the front. So we know that both triangles need to be identical. They're both going to be the same. So if we see 15 down here, we know that we can take that 15 and put it right there. And then we can put the other 15. This side is also going to be 15. Okay. Then we know that looking at the top of the triangle, we see a 9, and you can see this little tick mark on either side. And so that tick mark means that both are the same. So we have a 9 here, a 9 here, and because these triangles are the same, it's going to be a 9 on both sides. Okay. Then we're going to look here at the side length of the rectangle, and that's 20. And so if that's 20, it needs to be identical all the way, because otherwise it would overlap really weird. And so we're going to see 20, we're going to see 20, all of those are 20. Now, this is labeled on a triangle, but this side length also applies to here. So on the bottom one, the one that's bigger, we have 20 by 15. But on these smaller ones here, we have 20 by 9. You can think about it on the net here as well, because if this folds up and this folds up, they both need to be the same in order for the folds to match. Okay, nothing's folding up on the 15, so it's okay. But 9, 9, those are going to be the same. They're going to come together. Okay, so you notice that there's also this measurement right here that we haven't used yet, and that would be the measurement all the way up here and all the way up here. That is going to be your 5 centimeters. Okay, let's make that a little more productive. 15. All right, so that labeling out that net, that gets us kind of started. Now we need to figure out the area of our rectangles. So we remember that before. Area equals length times width, right? So if length times width, we're going to have 20 times 9. We're going to have 20 times 15. And we're going to have 20 times 9. Okay. Then looking at our triangles, we're going to have something a little bit different. In the triangle, we're going to use our base here. If we look back up a little higher, we see base times height divided by 2. Let's write it over here. Base times height divided by 2. So our area of triangle D, our base is going to be 15 times our height is 5 divided by 2. Okay. Let's put these together. Let's put a few numbers in here and then let's add that up. All right, so we've got, let's take a look at this, 20 times 9. In my head, I'm going to go 2 times 9 equals 18 plus another 0. That's going to give me, let's get back to our pen here. That's going to give me 180 centimeters squared, right? Down here, same thing, 20 times 9, 180 centimeters squared. Now I've got 20 times 15. So again, in my head, I'm going to go 2 times 15 is 30. I'm going to add that extra 0 to make 300 centimeters squared. And 15 times 5 is going to equal 75. Divided by 2 is going to equal 37.5. Go, okay. So we've got all of our areas. Oh, so this is the same for one, and this is the same for another one. We've got 2 of those, right? Centimeters squared, centimeters squared. So now I need to add those all up. So I've got 180 plus 300 plus 180 plus 37.5 plus 37.5. 2 triangles, 3 rectangles. Okay, so let's see if we can do this. We know 18 plus 18 is 36 with a 0, so 360 plus 300, that's going to equal 660. Now I've got 37.5 plus 37.5. I know up here that I divided by 2 to get that, so if I multiply by that 2, that's going to be 75. So that's going to give us a total of 735 centimeters squared. That's going to be our total surface area of that triangle, or that triangular prism. So if we added up all that side, the far side, the bottom side, the back side, all of that surface area would be 735 centimeters squared. Seems like a lot of steps. Hopefully it makes a little bit of sense. Feel free to rewatch this thing, watch it in slow-mo so that you can go back on it, or ping me a message for some assistance on that. Let's take a look at the next side on there. So we understand, hopefully, how this works with our nets. And so let's take a look again at looking at the formula. So just like our formula for the surface area of a rectangular prism, it's kind of long and complicated. So let's break it down a little bit here. All right, so this formula looks nuts, but let's just take a quick moment and break it apart. So we know that in our surface area, we need 2 triangles and we need 2 rectangles. So here we've got a triangle, rectangle, rectangle, rectangle. So that's what we're figuring out, just like our net back here, where we had to figure out the surface area of all those. Here, we're going to figure out the same thing, but we're going to use this fancy formula. So when we are, again, remember that the height here and here needs to be a 90-degree angle. So if you have one of these triangles, it's not, if you have a right angle triangle, or a right angle triangle, whatever that may be, you can just use the height. But if you don't have a right angle triangle, you need to use the height as is given to you here, okay, or calculated, measured there. Then the length you see is in every single one. The length is the distance that's the line connecting the triangles. So it's going to be the same on every single rectangle, but what is connecting the triangles, that's what's going to go there. And so it's going to be the same in each one. We see these little subscript 1, 2, and 3s here, meaning that there are 3 sides to the triangle. So you need to go length times one side of the triangle, length times the second side, length times the third side. You might have an equilateral triangle where all 3 sides are exactly the same, but probably you're going to see a lot of triangles that don't have the same sides. And so that's why we separate into each one so we can identify which one is which. Okay, let's take a look here. So we're going to start with writing out our formula. I know it's painful, but let's give it a shot. Surface area equals base times height divided by 2 plus base times height divided by 2 plus, I'm just going to go like this, length times width 1. Remember, if there's nothing in between, if you had 2x, that would mean they're multiplied. So if I go LW1, that means I'm multiplying length times width plus LW2 plus LW3. Okay. All right, let's plug in some numbers and see how it goes. So our base is 4 times our height is 3 divided by 2 plus, same thing, 4 times 3 divided by 2 plus, what is our length here? Our length is 11. So you know what I can do? I can just go like this. I'm going to put in 11, 11, 11. And then I'm going to put in my width 1. So I can pick whichever one. It doesn't really matter. So I can just go like this. 1, 2, 3. So width 1 is going to be times 4. Width 2 is going to be times 3. And width 3 is going to be times 5. Okay, so now I got 4 times 3 is 12 divided by 2 is 6 plus the same 6 plus 11 times 4 is 44. 11 times 3 is 33 plus 11 times 5 55. I love the 11 times tables, just so easy. Okay, so then, at least until you get to 9. So you might notice also here that we got 4 times 3 divided by 2 plus 4 times 3 divided by 2. So if I do that and divide it by 2, if I just took 4 times 3, it probably would work. If that is confusing to you, don't worry about it. But if you're like, hey, I think I could use this as a shortcut, go for it. Okay, so 6 plus 6, we've got 12 plus 44 plus 33, we got 77 plus 55, which could be combined with the 12 to make it into 67. So 77 plus 67, we've got a 14, so 144. Does that make sense? Check it with a calculator. Pretty sure it's good to go. I'm just going to rewrite that a little bit nicer. 144 centimeters squared. So I've got my equation or my formula. I've got the work that I've done. I've got my answer, my number answer, and I've got my units. So I need to make sure I have all 4 of those parts when I'm doing my work. Okie dokie. Let's take a peek at this last one. Now, oh man, it's a little bit different. It's a little wonky. It's presented in a completely different format. So let's see if we can figure it out. So we're going to just write down the formula here. Surface area equals base times height divided by 2 plus base times height divided by 2 plus length times width 1 plus length times width 2 plus length times width 3. Okay, so we know that our base is going to be 10. 10 times our height here, is it 13? No, it's right here, 12, okay? 10 times 12 divided by 2 plus 10 times 12 divided by 2. Now we've got length, which is 14, times, what side do we want to use first? Let's go like here, 1, 2, 3. So 14 times 10 plus 14 times 13 plus 14 times 13. Aha, it's the same. Oh, I ran out of space. You can kind of figure it out on the side there. So let's try this. 10 times 220 divided by 2. I'm just going to sneak this in here. So 120 divided by 2 is 60. So we go 60. That's not part of anything. That's just my thinking. 60 plus 14 times 10, 140, plus 14 times 13. I don't have that one in the old brain, so I need to put it in the old calculator. So 14 times 13, 182 plus, it's the same, 182 equals, let's see what we can do here. So 60 plus 60 is going to be 120 plus 140 plus 182 plus 182 equals what? 10,030. No, I'm just joking. What is it? 624. What are we working in here? Millimeters squared. Formula, work, answer. Units. I think that looks good. Let me know if you see any questions on it, though. So that covers our triangular prisms. Hopefully, between the two, it makes sense. Let's go back to our learning target. I can calculate the surface area of a right triangular prism. So we've taken a look through it using nets. That looks a lot messier now than it did when it was live feed. If you missed it, you better just go back and watch from the start. And we've looked at it using a formula. You can solve that whatever way you prefer. It does not matter. If you have any questions on that, let me know. You can tune in and ask questions during our math meeting when we gather, or you can shoot me an email and let me know how things are going. That's it. Signing off. We miss you. Take care of yourselves, and we'll see you soon.